So trig differentiation, we only need to, there are two which we don't derive, which we just mention as if they are identities. So if f of x is equal to sin x and g of x is equal to cos x, we say the derivative of f with respect to x is cos x, and the derivative of g with respect to x is negative sin x. But once you know these two, so if you know this, you know this, then you know every trig differentiation. So we are done. Since we said that the derivative of tan x is the same as the derivative of tan is sine x over cos x. So this is quotient rule. So we let u be sine x, v be cos x, but the derivative of u is cos x, the derivative of v is negative sine x. So the derivative of this guy is going to be u prime. So remember I said u prime v minus v prime u over v squared. That is u prime is cos x, v is cos x minus v prime negative sin x, u sin x over v squared, that is cos x squared. But the top guy here, cos is cos squared, minus minus is plus, sine is sine squared over cos x squared. You guys, we said, if you remember very well, that side aggregate, we said if you know this identity, then your life in mathematics, as far as trig is concerned, is stable. So that here we have 1 on top and cos x squared down. But we said that 1 over cos, because this can be written as 1 over cos and the squared out, because 1 squared is 1, cos squared is cos squared. 1 over cos is what? 1 over cos is sec. So we get sec squared x. This means that the derivative when h of x is tan x, the derivative of h with respect to x is going to be sec squared x. Okay, when y is equal to sec x, is the same as y is equal to 1 over cos. So we can differentiate dy dx is going to be, you will let u to be 1, so u prime is always 0 for n constant, v to be cos x, v prime is negative sin x. So u prime v is 0, then minus, so u prime v minus v prime u over v squared. This is 0 here, minus sin x multiplied by u, which is 1 over v squared, that is cos squared x. This is sine x over cos x multiplied by cos x. So that I write it as, sine x over cos x is tan x. And 1 over cos x is what? Is sec x. So the derivative of sec is tan x sec x. It's a special derivative. The function appears again. The derivative of, so we are keeping this. We are keeping this. Let's get the derivative of cosec. So this is 1 over sine. So again, u is 1, v is sine. And u prime is 0, v prime is cos x. So say dy dx u prime v minus v prime u over v squared. U prime is 0, so we have 0 minus v prime is cos, u is 1, so we get cos x over v squared, that is sine squared x. This is equal to negative cos x over sine squared x. Now cos over sine, that is cot. 1 over sine is cosec. So we are saying the derivative of cosec is equal to negative cot x multiplied by cosec x. This guy here. So we have 1, 2, 3, 4, 5. One more to go. Where do we write it? We'll write it here. The derivative of cot x. We'll bring it here and solve it from Pakonapa. So cot is the same as cos over sine. So we let u be cos x, v be sine x. And then u prime is going to be, derivative of cos is negative sine. The derivative of v is cos x. So we'll have u prime v minus v prime u over v squared. That is u prime is negative sine multiplied by v, which is sine, so we'll have negative sine squared x. And then v prime multiplied by u cos, that will be plus cos squared x over v squared, which is sine squared x. Complicated. So this one, I think it's not nice. Cos squared x minus sine squared x over sine squared x. Looks like you can simplify it, but I haven't yet seen the shortcut simplification. Yeah, I haven't seen it. And that's where you separate them. Cos squared over sine squared. Okay, I have seen. Cos squared over sine squared is, so you can write it. You can do this. Cos squared over sine squared. Cos squared over sine squared is cot squared. Then minus 1. Sine squared over sine squared. Yeah. So this is cot squared x minus 1. Maybe simplified. Yeah. So we have 1, we have 2, we have 3, we have 4, 5, 6. One and 2, we can't justify. We don't even know where they're coming from. But 3, 4, 5, 6, they are based on what we don't know where they're coming from. But at least we know now. So you first convince your mind to accept that the derivative of sine is cos, and that of cos is negative sine. Then you memorize it. Or you know it. Knowing and memorizing. So do you have any queries here so that we move to 2 more memory things?
Me, I'm having serious internet issues here. I'll come back in 5 minutes.
I couldn't hear. I was trying to connect what you're saying, but I don't know if anyone connected.
I mean, I never heard anything, so I've got your question.
Yeah.
On this last one here that we're doing, on this stage, I never heard what you said. My network is bad, so I wasn't hearing. What's the last one? The last one here, negative sine squared x plus cos squared x.
Over sine x. So it was
Is it sine
negative.
x or sine squared x?
Sine squared. So I said we can separate this like this. But the first one is just negative 1. Then cos over sine is cot. And since they are squared, it will be cot squared. You can write this as cot squared x minus 1.
Okay, thank you.
Okay. So I like this dirty board like this. Very, very nice.
Sir,
Uh-huh.
Janet said she's having network issues at her place, so she like keeps coming out and coming back in class because it's cutting, I think. Then she said she'll come back and ask. That's what I heard. So I don't know if that's what she said, but that's what she said.
Okay, we'll wait
Yes, that's
for
what I said.
we'll wait
No,
for
I'm
you
here.
coming back.
I'm here, but then the part. Okay, okay. Where I'll be stuck, I'll come. Even though it's not now, as in when I'll be stuck sometime, that's when I'll come back. That's what I'll say.
All right. Very, very nice. So you need to know 1, 2, 3, 4, 5, 6. We can now do general questions that will require these pieces here. Let's call them examples. Differentiate one f of x is equal to cos 3 2x. 2 f of x is equal to tan square x multiplied by sine 3x. Okay, let's start with these two. So the first one, we understand that we can write f of x as cos 2x to the power 3. Okay, and let u to be cos 2x, so that if we differentiate u, the first thing we do is to differentiate cos. It becomes negative sine, and then differentiate its inside, we get 2. Altogether we'll have negative 2 sine 2x. Go back to the question and write it in the form u power 3. Differentiate it, we'll get 3 u squared using power rule. And then chain rule says you must also differentiate the inside. So we have 3 u is cos 2x squared, and u prime is negative 2 sine 2x. So that 3 by negative 2, we get negative 6 cos squared 2x sine 2x. How is it?
It's just okay.
Okay. Let's go to 2. So this was 1. 2 product So let u be tan x squared, let v be sin x power 3. So you know that in u, you have something in u. So to get the derivative of u, you first drop the power, keep the inside from chain rule. The power now becomes 1. Then differentiate the inside. Derivative of tan x, we say this what? Sec squared x. What about v prime? We first drop 3. We have sin x, reduce 3 to 2, multiplied by the derivative of sine, which is cos x. Now we can write the derivative of f, which you can also present as f prime of x. It's going to be u prime v plus v prime u, product rule. So u prime is 2 tan x sec squared x multiplied by v, which is sine 3x, plus v prime, that is 3 sine squared x cos x multiplied by u, which is tan squared x, which is tan squared x. So it's a product there. So to avoid confusions with network, plus 3 sine squared x cos x tan squared x.
Sir, on the question, isn't not on the question, but on this previous one, what that's from, isn't it sine negative 3x?
Sine negative 3x.
After sec squared x.
After sec squared x. Oh, here.
Yes. Yes.
You're saying, isn't it what?
I'm saying the power, isn't it supposed to be negative 3? How has it changed to negative 2?
The power is not negative. The power is positive. This is sine 3x. Because here, this whole thing here is u prime. This is u prime, is it? Multiplied by v. V originally in the question. So if we go back to u prime, oh, okay, it's okay. I don't know if your question is still there.
It's okay.
Okay. Some more examples. Some more examples. Example 3. F of x is equal to sec squared x over sine x minus tan 3x. Solution. This is quotient true, so we let u be the numerator, sec x squared, and differentiate u. To differentiate u, we get 2 sec x to the power 1 multiplied by the derivative of sec, which is tan x sec x. On the first one here, derivative of sec is tan x sec x. Number 5, yeah. So this is the same as 2 tan x sec squared x. Then we get v sine x minus tan 3x. V prime sine x is giving us cos x minus the derivative of tan is sec squared. We put 3x and then differentiate 3x. So it will give us 3. Then substitute. So f prime of x is equal to u prime v plus minus u prime v minus v prime u over v squared. U prime, that's 2 tan x sec squared x multiplied by v, which is sine x minus tan 3x minus v prime cos x minus 3 sec squared 3x multiplied by u sec squared x. Everything divided by v squared sine x minus tan 3x squared. So when you're dealing with trig differentiation, you must be a bit careful. Because they tend to be too long and trick sometimes. Where you expect to have a short answer, you get to have a long one, like the derivative of sec squared x. You see sec coming back, being written twice in its derivative. So you get confused. Okay, so let's log out and log back so that we come and do some more examples of these same structures.